Hi guys, welcome back to another video. We're starting a new topic today. The topic is going to be thermochemistry. I normally teach this one last because it's, in my opinion, the easiest topic. It's quite relaxing for the end of the year, but chosen to do it now just because the first half of it there's not many experiments we can do, and when we're back in the lab I want to do as many experiments as possible, so I thought this would be a good time to teach it. Mr. Lie's class is already on this topic, so if you know anyone there, they might have already seen some of this stuff. So the first part of thermochemistry, there's three parts. The first part is periodic trends. So atomic trends is the first part. The second part is shapes, polarity, and Lewis diagrams. And the third part is energy changes. So shapes and Lewis diagrams is carrying on from level 2. We've got some new shapes to show you. And atomic trends, this is the first one. So let's get started. This was a meme I made in 2018 when I first taught this topic, and it was very relevant then, and it's lost its relevancy over the years, but I still like it. So there's four trends. The first one is atomic radius, or atomic size. You could think of this as, so how big an atom is. What this means is the atomic radius is the distance from the nucleus to the outermost electron cloud. So for this one, let me just get up my pointer out. This will be the nucleus of the hydrogen atom, and to the outer electron cloud is our atomic radius. So you know what radius is, from the center to the outside. Hydrogen's our smallest atom, and so it's got the smallest atomic radius. This was a nice meme I found. Pantene. But this is the real Pantene. Classic. So this is a version of the periodic table, what it'd look like under atomic size. Ooh, where to begin on this one? Alright, let's start looking down the table. We've got our hydrogen here, it's got one valence electron. We've got our lithium here with one valence electron. We've got our sodium here with one valence electron. So this is the group 1 of the periodic table. As you can see, as we go down the table, it gets bigger. With cesium, actually it's missed out francium down here, but that would be our biggest atom on the periodic table, francium. But cesium's our biggest one on this one. And why do you think it gets bigger as it goes down? Have a think about that. Well, there's a couple reasons, but the main reason is as we go down, each row we're chucking in another electron shell. So here we just have the one electron shell, here we have 2 electron shells, here we have 3 electron shells, 4 electron shells, 5 electron shells, 6 electron shells. So the more shells of electrons, the more the outer they're gonna hang. Okay? So as you go down, you're adding in more shells of electrons. Let's look at something here. Let's start at potassium, and let's go our way across. Jump into calcium, it gets a lot smaller. Going across, it gets even smaller still over here. Why do you think this is? This is something that you have to think about a little bit. It's a little bit more complicated. Okay. So here we're on our 4th electron shell, or I'm going to start calling them energy levels. Okay. Whenever you hear energy level, think electron shell. So we're on our 4th energy level here. This is all the 4th energy level. And so bromine and krypton are all in the 4th energy level. Same with potassium and calcium over here. So we're not adding or removing any shells. What we're doing though is we're adding more protons into the nucleus. So if you think about this, selenium, bromine, and krypton all have 34, 35, and 36 protons respectively. That's a lot of positive charge to be in the middle of the nucleus acting on these electrons. So think about this, the outermost electrons are feeling 35 of the nuclear charge, 35 protons. Over here they're only feeling 19. So what we're doing is we're going from 19 to 20 protons. That extra positive charge in the nucleus has acted on the electrons, making them get slightly dragged in. Okay? as we're not adding, notice here, we go from 36 krypton to 37. It's way bigger. That's because the next electron, as you add in this, is going to fill out a shell. It has to jump into the fifth energy level, or the fifth electron shell, and it suddenly got way bigger, because it can hang out a lot more now. The atomic radius decreases along and up the periodic table. So when I said hydrogen was the smallest, I lied, it's helium. Because same electron shell, but helium's got an extra proton in its nucleus. So helium, I lied to you, helium's the smallest, sorry. This is probably a better way to look at it. You've cut out the transition metals and you've suddenly just got, you can see that it's getting smaller as you go along and it's getting smaller as you go up. This is a nice GIF explaining it. So as you go down, it gets bigger. As you go up, it gets smaller. As you go across, it gets smaller. As you go back along, it gets bigger. Cool. So these are notes. Put these in your books so you have them for the end of the year. We've finished our atomic radii. That's all you need to know on it. An excellent answer would be, it would probably give you the data for like some of these. Like aluminium's 34 nanometers and magnesium's slightly bigger at 50 nanometers, and you just have to explain why. Okay? And you can explain why with these notes. So pause the video and write them down. Alright, thanks guys for watching.